LeetCode Problem 212 Word Search 2. So this problem gives us a m times n board of characters and a list of strings, which are words, and we have to return all the words on the board, right? So basically the words can be constructed from letters of sequentially adjacent cells. Okay, so basically what it means is this is the board, and then the words, let's say we get oath, pee, eat, and rain. So you can see on the board we have oath, O-A-T-H, and we have eat as well, right? E-A-T, even though it's in reverse, right? So this also this is a valid word, because if you go from this path, okay, uh, if it goes from this path and you go to the left, you have E-A-T, right? Okay, so let's start with a uh, let's talk about my approach. So my approach is to technically, I guess you can say, brute force all of the options in the board using depth first search. I'm gonna use this example instead, right? So let's say the words we have are the words. Instead of this, let's look at A, B, C, A, C, D, and A, B, D. Actually, I'll write it like this instead. So we have A, B, C, A, C, D, A, B, D. Let's add one more A, C, for example, right? Okay. So the first thing I'll do is I will uh, add all of this into a trie. If you don't know what a trie is, you can look at my other videos. I've explained how to create a prefix tree. But what the trie will look like, it will look like something like this. So A, B, C, and then A, C, D. So it's A, C, D, A, B, D. So here we have another D. Okay, so this will be marked as an end of a string. And I have AC, which is over here. So this is what the trie will look like. So what I will do is, from starting from this character, I will therefore search all the possible moves. So let's say if I go to the down first, so we have C. So in this case, we are looking for A and C. In this case, there is an A and C here, right? And since there is, we will put AC into our list that we will return, right? Okay. After that, let's say we go right, ACD. Okay, and since ACD is a valid string, we will put ACD into our list as well. And if we go one more step, ACDB, since there's no ACDB in our prefix tree, so we just have to return the recurse back, right? And when we recurse back, obviously we will not, when we reach to the outer edge of the board, we just return. But for this case, since this recursion is done, so we move on to the next character, B. Right, so same thing, you can go through here, and look at for the characters. Right, since none of the characters are here, so you can kind of get where I'm getting at. Right. Of course, just now I only went down, right? I'll also need to go to the right as well. Right, that's how depth first search works. I'm exploring all of the options from this character. So AB, so there's no AB here, but ABD, there is a ABD, so this will be put into our list that we will return. So essentially, we will just go through one by one, right? So this on C first, so go up. There's no AC. Right? Technically, when we reach here, you can just straight away skip this because there's no character in the words that starts with C, and the same thing with D as well, right? So at the end, only these three strings will be returned. Okay, so that's basically how my algorithm works. So let's see the code. Okay, so this is the trie node. This is the prefix tree that I'm going to use. We have a class trie node, This is the construction of the try node, right? Each try node will have 26 child, and of course the boolean that tells whether or not this node is the end of the node. I also have a function inside this class, which is the insert. This is to insert the word, which will construct our try like this. Okay, I will keep this try because this is what we are going to use. Okay, as you can see, when I first create the solution, I will construct a new try node in the root. And here are some variables that I'll be using throughout the two functions we have. We have the find words function and the depth search function. So I have the root. This is the return vector that we're going to return, the row and the column. This row and column will store the, where is it? Yeah, this row and column will store the length of the board, right? Because let's say if there is another board here, uh, E and F, then row will be 3, and no, row will be 2. Sorry, row will be 2, and column will be 3. Right, so there's 3 columns and 2 rows. Okay, I am drawing a lot, but hopefully this will all make sense. So that's about the variables I'm going to use. So let's start with the find word. So at the start, I will construct my prefix tree, right, using the insert function I've created. I won't go through how the insert function works. If you want to know how it works, I have videos that explain all of this before. But yes, I am inserting every word into the prefix tree. So this is my prefix tree. It looks like this. Keep in mind our word is, let me write it out again. So A, B, C, right, A, B, C, A, B, D. And then once done, so we have AC and ACD. So these are the 4 words that we are using. Okay, let's continue. Alright, here we have a nested for loop. This nested for loop will therefore search all of the characters in the board. For example, right now we have only 4 characters in this 2x2 board. So we start with A. I'm putting in the board the row and column, which is currently at 0, 0, the root, and a empty string. Okay, this empty string is the word, and I'll explain what it's used for later. Okay, so like all depth search, we have a if statement. This basically checks whether or not we're out of bounds. This will check whether or not we have entered a part of the board that is visited, right? So the visited characters I'm using is this dot. You can use whatever you want, but I'm going to use dot here. So if any of this is triggered, that means we are in somewhere we shouldn't be, and we'll just return. Okay, so we have the character. The character is now the board. The board's current character, which is A. So let me write it down. So the character equals to A, and the node, we are going to the prefix tree in the node. So currently we are at A, right? So we are over here. It's a different color. So let's try blue. Okay, so I'm at over here at A. Maybe blue is a bit worse. Let's try purple. Okay, so I'm over here at A. The node is not null, so we're good to go. If this were to be B, obviously we don't have a B in our prefix tree, then you just immediately return, and I'll return our ret, which is going to be empty. Okay, but in this case this is not. Actually no, it won't instantly return, you just DFS the next character. Just something I messed up. But yes, since we have A, we do not return the word. We're going to concatenate the words right now. Our word was originally like this. Now, since we concatenate, it will look like this A. Okay. If this node is the current end of a node, which is not, so we just ignore this for now. The board will replace this with a dot. So right now, this is a dot. And then we DFS row -1. Okay, row -1 is over here. So we do not do anything. This will just instantly return us. So we just row +1. Row +1 is actually row -1 is actually go up. Yeah, but row +1 is go down. Okay, so right now we're at C. Let me recurse. So the character is C. Our word, correctly, our node is equals to node's child, and the node is not null because we have a C here. I remember we have a C, so we're going here, and the word plus equals the board. So right now our word is equals to AC, right? Okay, so since this is a end of a node, right? This is a end of a node. Okay, AC is a n. Over here you see it's marked by circling. So what we do is we will push the word into our return. Okay, so we have a return here, obviously. So return equals to, we are pushing AC in. Do I need to write out the rest? I guess I can. So row is 2, column is 2, and then return we have AC. Okay. And then this is important. We are setting the n to false, right? So this will now be false. So I'll just color it. So this will now be false. The reason we are doing this is to prevent duplicate entries into our return vector. But yes, this is important. After that, we are marking this as a dot again. So this is a dot, and then it will go -1. Okay, -1 goes up, but up since this is a dot, right over here is a dot, so we will immediately return. When that happens, we go to down. Since down there's nothing here, so we go to the left. Left there's nothing as well, so we go to the right. Okay, we're at D now. Character is equals to D. The word is, okay, let's pull down a bit. So the node will go there, go here only. Okay, since the node is not null, we concatenate the word. So now our word is ACD. When that happens, we push back, right? Since this D is a end of a node, right? So we push back ACD, and then the end of the node will be deleted, right? So this will be erased, essentially. Okay, it's a bit messy, but hopefully you guys will get it. So we set it to visited node, coloring, and then we DFS again, but eventually you go up to B. And since when we go B, this node, this D node, right? This D node does not have a B character. So when that happens, we just return. Okay. So in return, since we have already explored all of the options over here, we just recurse back to where we start from, which is A. And this time we will try going to the left, right? Where this is visited. So essentially now our character, let me not delete that, but let's have another recursion. So now our character is now going to be B. The word is going to be, so let me just, oops. Okay, I will just leave it here because I don't think we're touching this side of the, I think we're touching this side of the try anymore since we're going this way now. Okay, so again, it's not a null node since we have a node here. It's not a null node. So we concatenate the word. So right now the word is A plus B. Okay, since this is not a end of the node, we don't need to do anything, but we have to mark this as visited. So I'm going to color this here, and then we DFS again. DFS again, so we're going down to D, and since D exists and exists as a end of a node as well, so character equals to D, word now becomes ABD, so we have to push back ABD into our return. And when it happens, we can go we can continue on to ABDC, but since there's no C here, right? There's no C here as well. So what we do instead is we go back. Okay, and when that is done, I think we've finished recursing all of the nodes we have, right? For specifically C and D, since we have our try only starts with A, so these two nodes will be ignored. So out of all these four, only ABD, AC, and ACD are inside the board, and we can double confirm this with our return vector. Okay, so I have to touch on this as well. So since we are referencing the board, so when we're done with our DFS, we have to put back what was the original character, right? So that's how just now you see when we have recursed from A to C to D to B. So when we're done with all of this DFS, so we're putting back the respective character. So this will become B again, D, C, and A. So we can continue on with the next character in the board. Okay, this is very this is quite a challenging problem. It took me a while to solve this as well, even using a try. But hopefully my explanation is sufficient. That's all I have to show. Thanks.